Let's wait for more 5 minutes, then we will start till only 16 students are here. Okay, so can I start? Fine, can go with this. Okay, so I hope it's visible to everyone. Yes. See, today we are going to discuss about data structure and algorithm. So I can share a few interview questions as well as the maximum questions you can get it from previous GAT exams, right? So they are more tricky and quite um, difficult as well as right. But once you get the concept, so might be it will help you to crack it very easily, and you can apply it for the any different concept as well as. So see what I have compiled today. Um, and see somebody will ask about data structure is about you have to be apply with the programming. Okay. This will not work standalone because the few companies they ask how you can reduce the complexity. So such type of questions they can ask in a data structure. Another type of suppose they will give some algorithms. Right. Today we are not going to discuss any sorting and searching algorithm, but they are very common right in an interview. They will ask about any sorting algorithm. They will ask some variations of the sorting algorithms. Just like suppose binary search is there, so there are a lot of variation in binary search. So that you can have to be again you have to understood when we start a searching element with the middle element, how we divide the word algorithm. Suppose if you do not apply the sorting, then what is the criteria? And see, you have to be find out whether this type of problem statement can we use the which type of searching algorithm or which type of sorting algorithm. So for every algorithm, there are some clue kind of just like binary search algorithm. So we understand if the elements are in a sorted order, and then you have to apply the search, right? So understand if the elements are already sorted, so that you can think about a simple binary search algorithm. So that's what hint I think you have to be find out. Suppose the lot of sorting algorithms are also there, right? We discussed. We are not going to be discussed today, but that you can go through this, the selection sort, right, insertion sort, and a few questions related to all this sorting algorithm, whether it is in place algorithm or not, whether it is a stable algorithm or not. A few questions can be raised on a Q learning, sorry, in a quick sort, right? Just like if we choose the pivot element randomly, then what is the what algorithm complexity? So these all type of questions. So these all are the direct question. Understand? Still, these questions are direct. When somebody asks, you just write down the algorithm for suppose like you have to sort it in increasing order, and then you are started writing the in any of the algorithms. Fine, irrespective of any programming language, but you're just writing, you initialize the word parameters, you declare the array, right? And then you are putting the word for loops conditions, and then you are checking some conditions for the what minimum element or maximum element, and then you are changing the positions. So see, there are a few more questions they can ask related to, just like um, what they can ask in this. Suppose you want to be check whether the list is already sorted. So then how your algorithm will be identified, and then it will be stopped. It should not be again the loop will be recursively called for the n times. So then your algorithm should be smart enough. Fine. So see, these things are related to your data structure as well as for see in the data when the data structures we open this topic, right? So everyone is familiar with the word arrays. So array is the word very basic data structure generally we use. So I can ask the what and primitive data types and non-primitive data types. So that's our simple questions, right? Anyone can ask. So for again language specific, you are able to be say these are the primitive data types. These all are the what non-primitive data types. Whether it respect to the C programming language, Java programming language, or maybe the Python or any other programming language, right? Which you are more comfortable, and then ready for the what next question. So in between, we will see the few questions as well as right. And the searching sorting is a very common topic. Anybody can ask right in an interview. So please look into the what sorting and searching algorithms very in very details as well as you are quite able to crack the algorithms. And if somebody asks how you can change this line of code and what happened, right? Any other version of this particular algorithm in place, right? Yeah, nahi hai, right? Like that. So there are a lot of theoretical as well as conceptual questions can be raised. That searching and sorting is about quite we used to do the practice, right? Even you guys have already implemented in your lab manual, right? And this all those algorithms are not that much difficult, so you can crack it easily. Fine. So let's see what we are going to be see today. So we are just going to discuss the memory allocations. Simple. The one we know the contiguous and linked and index. So indexing is the very important concept, right? So that will try to trap, right? If the few questions you are able to crack it in a very initial phase of data structure interview, right? Then definitely they will go into the what index. Uh, and that's a very important application of indexing is what we are designing any type of database system. So all database systems are designed on indexing. Fine. So that's the application of that data structure. Then arrays, linked lists, stack, queue, this all are you should familiar with this operation, the structure, right? And what type of algorithms, right? For insertion, deletions, right? For swapping any element, for joining, for splitting. So see, these all are the what operations which we can apply over the list kind of things. Fine. And then some other data structure. So the trees, graph, some higher dimensional, hybrid. So here are the difficulties comes, right? Because all such type of problems are generally complex problems. Your logic, your data structures, because it is used our previous data structures. That's right. So those concepts are really its matter, right? But sometimes they will ask a very basic things about it because it's depend the interviewers having how much they have a grip over such type of data structure. Otherwise, not possible. See, uh, I used to suppose as an interviewer ask, suppose you are having two classes, right? You have to make one class as a suppose student class and another class which is the what uh, suppose one is the what order class and another one is what the items which we are ordering. And now you have to be link for each and every order with what specific items. So now they can ask what type of data structure I can be used to link this two type of information. So then you are able to what connect. Okay, what type of informations are there for specific order for particular item? There are multiple orders are possible, right? The multiple people can also order the same things. So the lot of points are there. So how we can map it, right? So you can, if you are having a list, simple, then it is fine. The list in the sense of what array or linked list, whatever you can assume. Or I should have a what dictionary kind of data structure. So where I will associate it, each of the information with the what order ID. So see, means there the complexity. So you have to be think, and then how we can implement such type of data structure. Suppose if I'm using the Java programming language, right? So you might be aware about the collection framework. So that collection framework will offer all these data structures, right, with their methods, right? In the C and C++, it was quite difficult, right, to implement all such type of complex data structure. But if we are having some framework, so definitely it would be easy in that case. So whenever we are having different associations, so definitely you have to use some dictionary. So hash map. So mapping is the what concept we use, key value pair kind of things. So these all are the what complex things which is come. So and you should be aware about the what runtime complexity, space complexity, how you evaluate the run complexity. Suppose you say the n log n is the what particular time complexity of the algorithm. So how you will derive that n log n, right? Or whether it is n square. So that theoretical component, I think in that case, you should quite familiar. Okay, so which let's discuss the few things in a very short, and then we are open for the questions. So somebody have any specific questions and related to any of the data structure, so that we can take it after this. So memory allocations को हम classify कर सकते हैं very easily. The one is a continuous allocations, right? That's how our operating systems. So a lot of applications of this particular data structures are we can see in our operating system as well as. So how our RAM, ROM, how the memories get allocated, right? So these all are the what important applications of. So they are using that data structures in operating systems. We will find out all type of data structures, right? How we are storing process, how we are executing, right? So they use this tag. If we talk about the browser, what type of data structure they use, so that you can also see. I also use this tag data structures. Dynamic allocations, fine. Link allocations and index allocations. So this is the what broadly classified, I guess. So the continuous allocation say it's about the array. Linked allocation is what about the linked list. So yeah, so that's a typical definition. So now let me check it out. So in that way, see, this is what it's showing. We are allocating, we are assigning any of the object, any of the informations in our contiguous space memory location. Fine. So thing is what if you require any runtime locations. So if my array gets full, so you know that. So you need to initialize another array. So the thing is what the operations will get increased. So your previous data you should have to be copied into the another array. So then you can delete the all previous array like that. So that type of operations will be there. So that's mentioned here. That's what informations are going to be what assigned, allocated, and then new memories you have. So basically this is disadvantage. So array is more efficient when we are doing searching operations because it's a continuous, right? It's a homogeneous kind of things, right? But the searching is more faster. That's what main advantage of array. But as a memory point of view, right, it's not efficient because this is the extra operations which you have to be conduct, and then you can use it the newly array. That's why we use the concept of what dynamic memory allocation. So whatever the if space you want, that should be allocated and change, shrink kind of, right? In allocations, this is the what kind of things. So we know the linked list, right? Very well. We are using starting node, add, then we are going to add the informations with the address. So that's the two informations that you use always. Fine. One is the what information itself, and second one is what the address of the what next node. Like that. Similarly, it will be linked. Whenever you want to be add any of the information, any of the nodes, so then you can add it. Okay. So that data structures I hope you have implemented in a C and C++. Even if you go with a Java, so collection offer that linked list class. So with the help of that, you can make the what linked list very easily. And they also offer the what operation. you can recall the programming, right? So suppose somebody asks in an interview, do you know linked list? You say yes. So write a simple algorithm to insert a node on a specific locations, maybe starting of the positions or maybe the end of the position, maybe any other random location. So at least you must be aware in any of the programming language. Because if we are using the C or C++, right, in C you have to create the what structure of this particular node, right, the information and the pointers. And then during the calling you have to be check it out whether the list is empty, whether the list already having some element, so which is the starting element, the head you want to be changed or first element you want to be changed, and then related pointers, operations. In that sequence you have to be updated. Then only the new node will be get updated. So see, the linked list related lot of questions can be asked in an interview. Insert on a particular positions, delete the element, split the element, join two linked list, right? So such type of operations and the sequence of operations at least you should have in your fingertips. Then only you can write down and easily you can debate with them. That can be questions maybe in a second round of technical round, maybe possible, right? Where they are going to be what check your algorithm and your logic capability, right? So you should be have any one of language. So then your task will be more easy. Okay. So then you know, right, head, node, find how you are assigning initial, last node like that, and then we change our positions and the empty node, null node, how we represent. So this also depend on a language. This is a C++ code, right? Index allocations. So see the whole um, hashing concept, in the data structure, that's another important concept. The hashing में searching सबसे faster होता है, and then on an average it will take constant time, right? So how? So this is the possible with the help of that indexing. So basically it's combining of continuous allocations with the linked allocations. So then they have combined all these two theory, and then they come up with the index allocations kind of. So on average the searching is very fast compared. Right. So then again, how we can implement this? So this is also one kind of dictionary type of data structure you can say. So you have to map it each and every information and store into the body specific location. So see how our RAM, how we are assigning process into the word memory. So it's also again situations of dynamic, right? Where my RAM is available, how much RAM is available. Suppose I suddenly delete a process, so then this space will get available. So then the new process will be allocated easily. And then when we are again resuming the process, so this is again possible with this particular index. So again, you have to be recall it. So the very important applications, right, of this indexing and all. To index all this application in the operating system point of view. So then you will get it because you are using the operating system, so you can interpret more easily, right, how it's work. So matrices, right? So actually we represent the matrix in that form, but how it will be allocated in the form of the what index, basically. So for writing, it's very simple, right? So we declare the matrix of any size, but how it will be get indexed, right? You might have solved a few questions, the row measure column, row measure operation, and column measure operations kind of things. So when we are representing the information in a column wise or maybe the row wise, so like that, how, and if for any specific information if we want to search, right, so then again we have to calculate the particular index. So basically the informations are stored in that form, so that's why we calculate, and manually we also have done some numericals about it, right, that you can refer. Yeah, this is the order, row measure order and column measure order. So such type of examples you have already correct. So this is for the finding the what particular information. So how we can find it? So we can implement such type of allocations. See other allocations formats, right? You can say this is the tree, graph, TQ, and inodes. So actually, inodes the Linux operating system. So how the Linux operating systems use right the allocation and all these things. So this is the completely inode, right? So you can search that term. So the Linux and Unix operating systems, so they have used these particular inodes data structures for allocating the memories. Trees, right? We know that. So see, there are few questions they can ask. Suppose I want to be implement a tree by linked list, whether it is possible or not. Then if you want to implement, yeah, you say suppose it's possible. So how we will implement trees using linked list like that. So because see for a lot of data structure there is no any inbuilt structures available. So you can derive it, right? So for any data structures you can derive. Suppose I want to implement linked list using stack. How we can do it? So such type of questions they can ask. So you have to be first of all you have to aware about the specific operation of any data structure. Then you have to think about if I want to perform that operation, so how I can modify the existing operation. Right? So tree is a variation on a linked list. So each node points to an arbitrary number of subsequent nodes, right? Useful for storing hierarchical data, definitely. So whenever you are having such type of information, the level wise they are same, right? So that's what property of tree. For a specific level, all the information are same. Again, you go down, then again another level will be created. Again, all the nodes over that levels will having the same property kind of things, right? Storing sorted data. So this is also a very useful applications of the tree. So we are having heap sort, right? That type of algorithms when we apply the word sorting. So again, that sorting algorithms are if we implement in a form of the trees, right? So then it is more efficient compared to our other sorting algorithm. So we can also store it, right? In the tree we go, so we are having some B tree, B plus tree kind of. So these all are the again complex data structures in form of the trees we store. So informations are in the form of the tree. See, the tree is very common, right? See, when you go into the any directory as well as so it's maintained in a tree structure. Simple. The root node, right? Then the child nodes. Again, inside a child, another subchilds are there. So the whole structure is in the form of the trees only. Our directory structure you can take in a Linux directory structure. You can take the example. That's our tree structures they are using. If you delete any new folder, suppose you created a folder, so that folder will be created inside it. So again in that particular node only. Basically, they are using what trees data structure, hierarchical data, right? Now we tree do not have a cycle. That's what the property. If tree having a cycle, so then it will become as a word graph. So that's a major difference. Or you can say the tree is a what subset of the graph itself. So trees से related बहुत सारे algorithms है जो तुम्हें आने चाहिए. Binary tree क्या है, right? Binary search tree क्या है? What is a balance tree? What is the property of the balance tree? AVL tree क्या है, right? See, these all are the different types of tree. So and how we calculate. So when we do the recursion, right? So when we call the recursive functions, similarly, it will start from the end, then n by 2, n by 2, then again n by 4, n by 4, n by 4, n by 4, like that. So this how this particular tree is created for this particular recursion. So this is also stored in the form of the tree data set. For related to the tree, you should first of all you should have a clear understanding how we will represent as a programmatically. कि मुझे बोला जाए कि ये ट्री बनाना है बाइनरी सर्च ट्री. So first of all, how you are going to be frame the program and then represent the particular information as about root and child, subchild, sibling, like that. Then only you are able to perform operation. Right? Suppose I want to insert the node in a form of the tree, and it should follow the binary search tree property. और बोला जाएगा उसके ऊपर प्रोग्राम लिखो. So you know that के उसका root node होगा, then the left node should be the lesser than the root node, and the right node should be the greater than the root node. So you have to check it out for each and every case, and then accordingly you have to insert the word node over the proper position. And the few traversal algorithms are also there in case of the tree. So that in order traversal, pre-order traversal, post-order traversal. So sometimes they do not ask, right? Such type of questions you can find out in your GAT examinations, but I didn't face any such example related to the trees, right? But you can check it out, right? Graph is the again variants of the tree, you can say. Or tree is a subset of the graph, you can say. The thing is about the graph having the closed loop. That's it. The tree can also have, but that's a loop for the itself, but that we do not consider, right? So without loop, it's a tree. With loop, it's a graph. So a tree also having some applications, right? I want to be check the connectivity of this particular. The similar way, the graph can also use the connectivity. So again, we are having few travels or algorithms. So graph having their own characteristics, right? We are having node, we are having edges. How the node and edges are connected. That's a property. The graph having a lot of application on that graph theory used in a machine learning, right? But the complex network, how they are, how these particular informations are associated with this, and we are going to be explored. So that's again a high level concept, but they use the word graph to represent that particular information. So basically, the graph having a lot of applications. Computer network is the one you can see that's one kind of network you can say. So each and every node are connected somehow, right? Graph having a lot of application. So that's what representations. Suppose the one graph is given to you, right? Then it will ask how you can represent it. Fine. So that diagonal is what your information. So if we are having self loop, then this value will be there. Otherwise, no. And then some other nodes, how they are connected with each other. So we are having different representations. We call as that what array representation or adjacency matrix representation. Similarly, linked list kind of representations are also there. So suppose if we are representing the graph in a form of the array, you can see the lot of cells which are blank, right? So it's again loss of memory. Understand? Because only the few cells which are available having some meaningful information. Otherwise, rest of the cell are what empty only. So this space is unutilized completely. That's a linked list representation. But this is more as a memory point of view. This is more a good approach. Even we are using array with a linked list. So the whole node will be the array, and then each and every node which are connected with others, that we represent as a what linked list. So that's more efficient way. That's because of the hybrid approach. Array and linked list, what they have merged to represent the what graph. So graph is again high level data structure, but for implementing the graph, we can use array and linked list. For tree as well as we can use the what linked list to represent the information. So a lot of operations you can perform, right? The linked list or array and dequeue the element, add the element. You can see here, for the example, the alphabet could be stored either as an array of 26 entries, you can see like that, or the linked list form we can have. So one linked list having 8 entries. Similarly, another next linked list having another 8 entries. So that's what address is stored by age, right? So then it will point to the what I. So likewise, we can have our informations divided into the sub informations, and collectively you will get the what complete information. Right. So the inode which we are talking, right? So that is the what data structures, the bigger data structures I can say that they have used, right? Um, so to represent the word memories. So this is a complete concept they have used, they have implemented in our Unix operating systems. So for representing information, all memory utilizations with a efficient way. See, this is what just high level data structure. So that's the application level you can check. So how this hybrid data structure they have used, right? So in the Unix file directory and file system is basically designed this particular data set. So application point of view, you can say. Such type of hybrid structures, hybrid data structure they have used to develop the Unix level directory structure. The runtimes of the algorithm, see, we implement the algorithms, right? And so see, whenever we calculate the complexity, it should be the generally we focus on the time complexity, right? How much time it will take to execute this. And the analysis, whatever we do, we perform for the n time of data set, n. So the length of the data set is n time. And then we compare the efficiency in terms of the what if size is bigger, if size is smaller, then how it will be performed. And then we have some kind of worst time complexity, best time complexity, and average time complexity. So you should have a scenario, right? That is the case when the algorithm will perform worst. And we always consider as what the worst time complexity, right? So how much bad the algorithm can perform if the logic is this. And then always the algorithm have a best case, right? Where the time will be very minimum. So that's depend on the what the algorithm logic. So suppose if I say we will use the following matrix to describe the operations and the location within the structure, right? अगर हम find करते हैं at first तो क्या होगा at arbitrary location, then what happen at nth positions, then what happen, or whether we insert element, whether we delete that, then what happen, right? That we can see. If we tag the sorted list, if the list is already sorted, right, in increasing order, maybe decreasing order like that, then the running time will be the what? How much time it will take, whether it is a good, bad. So that's just mentioned here, simple. The thing is, what you just have a asymptotic notation related complexity, so that you can say and you can compare it. Suppose as a quick sort, if it is performed worst, so what is the complexity? If it is performed best, so what is the case? And what is the complexity? Like that. Fine. So if it is a sorted list, if I want to search the element on the first position, so that's a good, because it will take order of one time only. Or maybe list so that it is having the index, right? So over the index you will get the value, right? Operation on the list, so at arbitrary location, so it will perform bad, right? Remaining case are good for any nth positions, so then position is given, so then this is more efficient. Fine. In form of the list, right? So this is a list and sorted list we are talking about. So see what I'm showing you here. Basically, you should have a complexity wise information. So then it is more better. So you can have a comparisons with all the complexity, and then you can make a table. So and then look every day what is the complexity of each and every algorithm with respect to this all cases. So that you can remember it easily, and then you can say about the two algorithm why it's better than other algorithms. So you have a complete answer, and also having some complexity parameters, right? So in the linked list, see a lot of variations you know. If it is a doubly linked list, so then operations are more operations get increased, right? But the accessibility will be more faster. So that's why you can see here. So that's our doubly linked list. So then automatically the operations become more efficient. So whether you want to find the element on the front or back, it is performed well, because for front you will have informations, for back you will also have information. For arbitrarily it will take time, right? You have to find out the particular location, then it will take. For insert, it's very efficient. For deleting, it's also very efficient operation. So then see the structure get complex, so then complexity get reduced. Simple. Fine. So if you want to go with this, you can refer this Waterloo University lecture material, I think. So then you will get a lot of materials with example, and then their exercise are also there. Generally, when I take the subjects, right, so I refer their subjects, their course material, and update my material, and then take it in a classroom as well, so that you can find out there. Even you can check it out the few problems, right, over the HackerRank. So how the problems can be asked, and then you have to find out uh, whether these problems require such type of data structure, which type of data structures are more sufficient. Sometimes you will not get it कि यहाँ मुझे कौन सा sorting algorithm apply करना है. So then you are having few 5 to 6 algorithms, right? But you are not able to identify which sorting algorithm will be the best for this scenario. So you just find out the problem statement or the hackering as well as you will get it. So then your implementations, your understanding and use of data structure will enhance. So these are the few things, right, which I want to be want to discuss with you, right? So that's I have covered. Fine. All this you can check it out. Sorting searchings are very common, right? Array, linked list, stack, and queue. These data structures generally they will ask. And in case of linear, if they talk about the non-linear, so the tree and graph. Inside a tree and graph, there are a lot of algorithms are there. So generally, in initial phase of interview, they will not ask about trees and graph. But definitely, when the complexity will increase, right, and they are looking for any good data structure people, right? So an algorithmic people. So then definitely they will go inside. But if you know some frameworks, right, through which we can develop such type of data structures, and you can use it in build methods. Then your task will be more easy, right? This is all from my side. If anyone have done any exercise and have any issue in any problems on any specific data structures, any questions, right? So you can share it here and can discuss further. Tell me if anything from your side. I don't know how you guys are preparing. Fine. Any question? Anything you can share? How you are preparing for your interviews and all?
Okay, bhai.
Okay. Anything?
मीटिंग चाहे तो पकड़ पकड़ के पूछे.
Okay. So see, HackerRank and CodChef, these all are the I think platform you can use, right? Definitely, and then try to understand the problem statement. Nowadays, the companies are also conducting the online uh, return and online interview. So definitely, they use all such type of problem statement in their time limits. If they will share, okay, yeah, you will have a return over this particular algorithmic round, right? डेफिनेटली सच टाइप ऑफ प्रॉब्लम्स दे रेफर विद हैकरिंग एंड कॉन्सेप्ट तो अगर वहां से कुछ प्रॉब्लम्स अगर करके रखोगे तो देन इट इज बेनिफिशियल. Any questions? Anything? Tree and graph are quite complex, right? So maybe um, if you can, if you have a basic knowledge and quite simple how you can implement, so this is also enough, right? Right now. See, if you're talking about Amazon interview, right, where they will ask 2, 3 rounds, they conduct about the algorithmic only. So then that data structures are little bit you have to be covered, right, in more depth. Otherwise, some other companies normally they will not ask much. So it depends on the what company and level of, right. Otherwise, people they generally they ask about array, linked list, stack queue, kind of, right, and searching and sorting algorithms. So that knowledge, if you have with the programming touch, so then your task will be more easy. Fine. Should I end it here? Anything? Any questions? Okay, so you can ping me anytime. You can just post me or you can WhatsApp me. You can email me any doubt, any questions, right? So then we can connect it. You can solve your problems. Fine. Just you have a basic. Basic should be most clear. So that's what I'm simple. Okay, so with this I'm ending here.